September 21st, 1942, Boeing Plant 2, Seattle, Washington. The riveting gun's pneumatic hammer echoes through the cavernous assembly hall like machine gun fire. Eddie Carlson's hands are steady despite 48 hours with only 4 hours of sleep. He drives another aluminum rivet into the bomber's fuselage skin, the metal still warm from the forming press. Around him, the organized chaos of wartime aircraft production surges forward with an urgency that borders on desperation. Section 47 complete. Someone shouts over the industrial din, moving to pressurization seal installation. Eddie steps back from his workstation, wiping sweat from his forehead with a greasy rag. Before him looms the partially assembled forward fuselage of what Boeing is calling the B-29 bomber, so advanced, so unlike anything previously built that even the engineers designing it aren't entirely sure it will work. The aircraft is still technically experimental. The first prototype hasn't even flown yet. But the assembly line is already gearing up for mass production because the Army Air Forces has made an impossible demand. We need this bomber operational within 18 months. 18 months. From drawing board to combat missions over Japan. It's insane. Carlson, they need you on the wing spar attachment. His foreman, Jack Reeves, waves him toward the center of the assembly floor, where a massive wing section hangs from overhead cranes. Reeves is a 20-year Boeing veteran who's built everything from biplanes to the B-17 Flying Fortress. But even he looks overwhelmed by the B-29's complexity. The night shift is arriving even as the day shift continues working, doubling up because there aren't enough hours to meet the production schedule through normal means. Swing spar, the main structural beam running through the wing, is a masterpiece of engineering that makes Eddie's head hurt when he thinks too hard about the stresses it must withstand. That makes Eddie's head hurt when he thinks too hard about the stresses it must withstand. The B-29 has a wingspan of 141 feet, nearly as wide as a football field is long. Those wings must lift a fully loaded aircraft weighing 120,000 pounds, twice the weight of a B-17, and they must do it while flying at altitudes where the air is so thin that unpressurized crew would lose consciousness within minutes. We're attaching the center wing section to the fuselage, Reeves explains, pointing to the massive join where wing meets body. This connection transfers the entire weight of the aircraft through these mounting points. Tolerances are critical. One mistake here and the whole wing could fail in flight. Eddie nods, understanding the weight of responsibility. In 3 months, someone will fly this aircraft. Someone will trust their life to the rivets he drives, the seals he installs, the connections he makes. There's no room for error, no time for second-guessing, and absolutely no possibility of slowing down. Across the plant floor, a group of Army Air Forces officers watches the assembly process, with expressions mixing awe and anxiety. Among them is Colonel Leonard Harmon, the military liaison overseeing B-29 production. He holds a clipboard thick with production schedules, engineering specifications, and progress reports. The clipboard represents the impossible, a plan to build the most advanced bomber in the world faster than any aircraft has ever been developed. The pressurization system is still having issues, an engineer tells Harmon, his voice tight with stress. The seals aren't maintaining pressure differential at altitude. We're redesigning them, but it's slowing everything down. How long? Harmon asks. 2 weeks, maybe 3. You have 1 week. The aircraft flies in 6 weeks, whether the pressurization works or not. We'll fix it in flight testing, if necessary. The engineer's face goes pale, but he doesn't argue. Everyone understands the timeline. Everyone knows what's at stake. The B-29 Superfortress, officially designated the Boeing Model 345, represents a quantum leap in aviation technology. Pressurized crew compartments, allowing operation at 30,000 feet. Remote-controlled defensive gun, turrets operated by gunners sitting inside the pressurized cabin. For Wright are 3350 duplex Cyclone engines, each producing 2,200 horsepower and burning aviation fuel at a rate that makes logistics officers weep. Range, 3,250 miles. Bomb load, 20,000 pounds. Speed, 350 miles per hour at altitude. On paper, it's magnificent. In reality, it's a collection of untested systems, experimental technologies, and engineering solutions that won't be proven until someone risks their life flying the prototype. And that prototype is taking shape right here, right now, assembled by workers like Eddie Carlson, who understand that speed matters more than perfection, that good enough has to be good enough because the alternative is unthinkable. Listen up. Reves shouts, his voice cutting through the industrial noise. Second shift is staying for hours overtime. No exception. We're behind schedule on fuselage assembly, and we need to make up time. Anyone who can't stay, see me now. Nobody moves. They're exhausted, running on coffee and determination, working hours that would be illegal in peacetime. But this isn't peacetime. Across the Pacific, American forces are fighting desperately to hold islands with names most Americans had never heard of 6 months ago. Guadalcanal, Tulagi, Henderson Field. The strategic situation demands a bomber capable of reaching Japan from bases in China or India or eventually the Mariana Islands if they can be captured. The B-29 is that bomber. The only bomber that can do it. But only if they can build it fast enough. Eddie returns to his rivet gun, loading another aluminum fastener into the chamber. The metal is cold against his fingers despite the plant's heat. He positions it carefully, squeezes the trigger, and the pneumatic hammer drives it home with a satisfying thunk. One rivet, one of thousands. One small piece of an impossible puzzle that must somehow come together in time to change the course of the war. Around him, the assembly continues. Welders spark. Cranes hoist. Engineers argue over specifications. And slowly, impossibly, the B-29 Superfortress takes shape born from desperation. Built at unprecedented speed and carrying the hopes of a nation that needs it to work. September 21st, 1942, Boeing Field, Seattle. 6 hours later, test pilot Edmund Eddie Allen climbs into his car just as the second shift's overtime ends. Through his windshield, he can see the floodlit assembly plant still blazing with activity even at 2 in the morning. Allen is 44 years old, considered by many to be the finest test pilot in America. He's flown everything Boeing has built for the past decade. But nothing in his 20 years of flight testing has prepared him for what's coming. In his briefcase sits a preliminary flight test plan for the B-29. Preliminary because the aircraft doesn't exist yet in flyable form. The first prototype is still weeks from completion, but Allen is already planning how to test it, how to push it, how to discover its limitations before those limitations kill someone in combat. Allen drives through darkened Seattle streets, his mind already working through flight test sequences. First flight will be basic handling takeoff, climb, level flight, landing. Assuming the aircraft doesn't shake itself apart or exhibit some catastrophic design flaw. Second flight will explore the flight envelope, higher speed, steeper turns, stress testing. Then altitude tests, pressurization verification, engine performance at various power settings. Each test carries risk. Each flight ventures into unknown territory. But the Army Air Forces isn't giving him the luxury of cautious, methodical testing. They need data fast. They need to know if the B-29 works, and they need to know now. December 15th, 1942, Boeing Field, first flight. The B-29 sits on the tarmac like a metallic leviathan, its polished aluminum skin reflecting winter sunlight. Eddie Allen walks around the aircraft slowly. his trained eye checking control surfaces, landing gear, engine nacelles. Everything looks correct. But looking correct and being correct are different things. Engines are warmed up, says his flight engineer Robert Dunsfield, emerging from the forward hatch. Oil pressure nominal. Fuel system checked. She's ready as she ever be. Alan nods, his expression unreadable. Around them, hundreds of Boeing workers watch from the assembly plant's windows and doorways. Army Air Forces officers stand on the observation platform. Photographers position their cameras. Everyone understands this moment's significance, the first flight of an aircraft that might change the war or might be an expensive failure. The crew boards. Alan in the left seat as pilot, co-pilot in the right seat, flight engineer, navigator, radio operator. The noise is tremendous even inside the pressurized cabin, a thrumming vibration that resonates through the airframe. Alan advances the throttles slightly, feeling how the aircraft responds. The brakes hold against 8,800 horsepower, trying to push the bomber forward. He checks instrument cylinder head temperatures, manifold pressure, RPM gauges. Everything reads normal, but normal is relative when testing an aircraft that's never flown. At the runway threshold, he runs through the final checklist. Control surfaces checked, trim tabs set, mixture rich. Props full forward, cowl flaps open to maximum cooling. The engines sound healthy, their synchronized roar filling the cabin despite soundproofing that didn't exist in previous bombers. B-29 Urt, cleared Kopfkopf. Alan takes a breath. This is the moment, the point of no return. He advances all for throttles smoothly, keeping his eyes on the runway centerline as 8,800 horsepower pushes the 105,000-pound aircraft forward. The acceleration is impressive, not fighter-like, but strong for a heavy bomber. 50 knots, 70. The tail comes up as designed, 90 knots. The flight engineer calls out speeds 100 knots, 110, 120. At 135 knots, Alan eases back on the control yoke. The nose lifts. The main gear breaks contact with concrete. The B-29 Superfortress flies for the first time, climbing into cold December sky with an ease that belies its massive size. Gear up, Alan orders, and feels the aircraft clean up as the landing gear retracts into the nacelles. Airspeed increases. Rate of climb holds steady at 800 feet per minute. The engines run smoothly, temperatures within limits, no vibrations or unusual sounds. And there's a vibration at certain power settings that Alan doesn't like. A subtle resonance that might indicate a problem with engine mounts or propeller balance. Still, the flight is successful. Alan brings the bomber around for landing, configuring flaps and gear, managing his descent profile with the precision of 20 years' experience. The touchdown is smooth main gear first, then nose gear settling gently. He applies brakes and reverse thrust, and the B-29 slows to taxi speed. On the ground, Boeing workers erupt in cheers. The first flight is complete. The bomber works. But working and being combat ready are vastly different things. Over the following weeks, Alan and his test crew fly the B-29 almost daily, accumulating flight hours at a rate that horrifies traditional test pilots. Each flight reveals new issues. Engine overheating persists. The right R3350S run chronically hot, especially during climb. Solutions are attempted: modified cowlings, improved baffling, different cooling louvers. Nothing completely solves the problem. The pressurization system develops leaks. Seals fail. Bulkheads crack under pressure differential. Engineers redesign components between flights, installing modifications almost immediately and testing them the next day. It's trial by fire, learning through doing rather than careful analysis. The remote gun turrets malfunction. Ammunition feeds jam. Fire control computers miscalculate. Hydraulic systems leak. The list of problems grows daily. But so does the list of solutions. Boeing engineers work alongside Army Air Force's technical specialists, fixing issues as they're discovered, sometimes creating solutions overnight that would normally take weeks of design work. The pressure is immense. Production aircraft are already being built on the assembly line, hundreds of B-29s taking shape, based on a design that's still being tested, still being modified. It's backwards, Alan tells Colonel Harmon after a particularly difficult test flight. We're mass-producing an aircraft that's still experimental. If we discover a fundamental flaw, something that requires major redesign, we'll have hundreds of incomplete bombers that need rebuilding. We don't have a choice, Harmon replies flatly. The strategic bombing campaign against Japan depends on the B-29. The president himself has prioritized this program. We build it now and fix problems as we go, or we don't build it at all. Alan understands the logic even if he doesn't like it. Traditional aircraft development, careful design, prototype testing, refinement, then production takes years. The B-29 program is compressing that timeline into months through brute force and parallel development. Design, test, and production happening simultaneously, each informing the others in real time. It's chaotic. It's risky. It's the only way to get the bomber operational in time. Eddie Carlson, now working on the 15th production B-29, sees the results of test flights translated into engineering changes almost immediately. Modified engine baffles, reinforced pressure bulkheads, improved ammunition feed systems. Each aircraft coming off the line incorporates lessons learned from flight testing, creating a situation where early production B-29s are already obsolete compared to later versions. It's like building the railroad while the train is running on it. Carlson tells a new worker, a young woman named Helen who transferred from a munitions plant. We're making it up as we go, fixing problems we didn't know existed until someone flew high enough or fast enough to find them. But it's working. Slowly, painfully, expensively, but it's working. The B-29 is becoming real, evolving from experimental prototype to operational weapon through sheer determination and unprecedented industrial effort. February 18, 1943, 5,000 feet above Seattle. Eddie Allen's voice crackles through the radio with professional comm, but the Boeing tower operators hear the tension underneath. Tower, XB-29 experiencing engine fire number 1. Declaring emergency. Requesting immediate landing clearance. B-29 cleared for emergency equipment standing by. Inside the cockpit, Allen fights to maintain control as flames stream from the inboard port engine. The fire suppression system has failed to extinguish the blaze, and the fire is spreading, not just consuming the engine, but eating through the magnesium components and moving off toward the wing's fuel tanks. He's already shut down the engine, feathered the propeller, but the fire continues burning with terrifying intensity. We need to get this thing on the ground now, co-pilot Robert Dansfield says, his hands gripping the control yoke as he helps Alan manage the dying aircraft. Alan nods, beginning a descent toward Boeing Field. The B-29 handles sluggishly with one engine out and fire damage affecting the wing structure. Through the left cockpit window, he can see flames now visible along the wing leading edge. The fire is out of control, burning through aluminum skin and structural members. They're 3 miles from the field when the wing structure begins to fail. Alan feels it first as a vibration, then as a sickening looseness in the controls. The left wing is losing structural integrity, weakened by fire damage. He needs another 2 minutes to reach the runway. He might not have 2 minutes. Brace for, Alan starts to say. The wing fails catastrophically. The outboard section separates from the aircraft, taking the number 2 engine with it. The B-29 rolls violently left, the asymmetric lift and thrust overwhelming Alan's control inputs. He fights it, using every ounce of skill accumulated over 20 years, trying to level the wings, trying to maintain some semblance of controlled flight. But physics is unforgiving. The bomber rolls inverted, nose dropping into a steep dive. Allen and his crew 10 men total have perhaps 5 seconds to understand what's happening before the B-29 impacts a meatpacking plant on the southwest edge of Seattle at 250 miles per hour. The explosion is visible from the Boeing plant. Workers at the assembly line windows watch in horror as a fireball erupts into the February sky. 20 people die in the crash. Allen's entire crew and 11 workers in the meatpacking plant. The B-29, the aircraft that was supposed to win the war, disintegrates into burning wreckage spread across to city blocks. February 19, 1943. Boeing Plant 2. Emergency meeting. The conference room is silent except for the scratch of pencils and rustle of papers. Colonel Harmon stands at the head of the table, his face grey with exhaustion and grief. Around him sit Boeing engineers, Army Air Forces technical specialists, and representatives from Wright Aeronautical, the company that manufactures the problematic R3350 engines. "We've lost our best test pilot," Harmon says quietly. "We've lost an irreplaceable prototype. And we've lost time we don't have to spare. The question before us is simple. Do we continue or do we halt the program?" A Wright Aeronautical engineer speaks up, his voice defensive. "The engine fire was caused by a failed intake manifold. We've identified the weak point and can redesign it within." "Within how long?" Harmon interrupts. 6 weeks. Maybe 8. "We don't have 8 weeks. Production aircraft are coming off the assembly line daily. We have contracts for 1,600 B-29s. The 20th Air Force is being formed specifically to operate this bomber. The entire strategic bombing campaign against Japan is predicated on the B-29's capabilities." Harmon's voice hardens. "We cannot stop, we can only fix the problems and continue." A Boeing engineer named Philip Larson leans forward. "The R3350 engine is fundamentally flawed for this application. It's too powerful, running to hot into confined space. We're asking it to produce 2,200 horsepower continuously at altitudes and temperatures it wasn't designed for. The engine literally cooks itself. Then we fix the cooling," Harmon replies. "We modify the cowlings. We improve the baffling. We do whatever is necessary." "What if it's not enough?" Larson asks. "What if the engine can't be made reliable within the operational parameters we need?" The question hangs in the air. Everyone in the room understands the implications. The B-29 is designed around the R3350. There is no alternative engine available with sufficient power. If the engine is fundamentally unsuitable, the entire program fails. But failure is unacceptable. The strategic situation demands the B-29. American forces are slowly advancing across the Pacific, island by island, but Japan itself remains beyond the range of any existing bomber. The B-17s and B-24's devastating Germany cannot reach Tokyo from any available base. Only the B-29, with its 3,250-mile range, can bring the war to the Japanese home islands. "We make it work," Harmon says finally. "We test modifications on the ground until we're confident they'll hold. We modify every aircraft on the production line. We train crews to manage the engines carefully, to monitor temperatures constantly, to shut down at the first sign of overheating. We do whatever is necessary because there is no alternative." Eddie Carlson hears about Allen's crash from Jack Reeves during the shift change. The news spreads through the plant like wildfire, whispered conversations, shocked faces. The sudden understanding that the aircraft they're building has just killed the man who knew it best. Are we still building them? Someone asks. Yes, Reeves replies firmly. We're still building them. Alan would want us to finish what he started. But the enthusiasm that carried the program through its early days has been replaced by something grimmer determination. Born not from excitement, but from necessity. The workers understand now that speed has costs. That pushing technology forward at unprecedented rates means accepting risks that would be unacceptable in normal times. The assembly line continues. Riveters drive fasteners. Welders join aluminum sections. Electricians run wiring through newly designed fire suppression systems modifications implemented immediately after Alan's crash. Every B-29 now includes additional firewall protection around the engines, improved fire detection systems, and redundant fire extinguisher bottles. Will it be enough? Helen asks Eddie as they work side by side installing engine cowling components. I don't know, Eddie answers honestly. But it's what we've got. And guys are going to fly these things into combat whether we've solved every problem or not. Our job is to give them the best chance we can. June 1943, Wichita, Kansas, Boeing plant. The B-29 production has expanded beyond Seattle. New assembly plants in Wichita, Omaha, and Marietta, Georgia are coming online, each building hundreds of bombers. The industrial mobilization is staggering thousands of workers, millions of square feet of factory space, supply chains stretching across the continent, all focused on producing one aircraft. Lieutenant Colonel Paul Tibbets, who will later fly the Enola Gay over Hiroshima, visits the Wichita plant to observe production and meet with crews training on the new bombers. He's impressed by the aircraft's capabilities but concerned by persistent reports of engine problems. How many flight hours do we have on the R3350 now? He asks a technical officer. Approximately 12,000 cumulative hours across all test aircraft and early production models. And the failure rate? The officer hesitates. Higher than we'd like. We're seeing engine failures every 200 to 300 flight hours on average, usually overheating related. Tibbets does the math quickly. A combat mission to Japan and back might require 14 hours of flight time. If engines fail every 250 hours on average, each aircraft might complete only 17 or 18 missions before suffering catastrophic engine failure. In combat, with no emergency landing fields available over the Pacific, an engine fire means ditching in the ocean if the crew survives long enough to ditch. That's unacceptable, Tibbets says flatly. Yes, sir. Wright Aeronautical is working on modifications. Improved cylinder heads, better cooling fins, revised fuel injection systems. Each production batch incorporates improvements based on testing. It's the same answer everyone gives. We're working on it, we're improving it, it'll be better on the next one. But better and reliable aren't the same thing. The B-29 is being rushed into service, with known, serious deficiencies because the alternative waiting until everything is perfect means abandoning the strategic bombing campaign against Japan. On the production floor below Tibbets, workers assemble B-29 number 387. It's a Tuesday afternoon. The aircraft will be complete in 6 days, flight tested the following week, and delivered to the Army Air Forces 2 weeks later. From raw materials to combat-ready bomber in less than a month of production, rate that would have seemed impossible 2 years ago. But speed has its price. Alan's death proved that. And as more by 29 center service, more crews will discover the bomber's limitations firsthand. At altitude, over enemy territory, where mistakes and mechanical failures are measured not in repair costs, but in lives lost. The production continues anyway because war doesn't wait for perfect solutions. It demands action, Demands results, demands that engineers and workers and pilots do the impossible and do it now. And somehow, impossibly, they do. June 5th, 1944. Chengdu, China. Forward Operating Base. Captain Robert Morgan stands beneath the wing of his B-29, christened Dauntless Dottie, and watches the ground crew perform pre-flight checks. Heat is oppressive 110 degrees Fahrenheit with humidity that makes every breath feel like drowning. Sweat soaks through his flight suit before he even climbs aboard. Around him, 47 other B-29s of the 58th Bombardment wings sit on the hardstand, their silver skins shimmering in the brutal Chinese sun. Today marks the first B-29 combat mission from mainland China raid against Japanese rail yards in Bangkok, Thailand. It's taken 18 months to reach this moment. 18 months from Eddie Allen's first test flight to operational deployment in the China-Burma-India theatre. 18 months of crashes, modifications, training accidents, and desperate engineering fixes. Engines are good to go, Captain, Staff Sergeant Jimmy Walsh reports, wiping grease from his hands. Number 2 is running a bit hot on the ground, but that's normal for these birds. Should cool down once you're airborne and get some ram air through the cowlings. Morgan nods, but the mention of engine overheating triggers memories of accident reports he's read during training. Engine fires remain the B-29's most persistent problem, despite 2 years of modifications. The Wright R3350S produce incredible power, but they do it by running at temperatures that push materials to their limits. In the tropical heat of the CBI theatre, those limits are even closer. Keep an eye on those cylinder head tongue, Jimmy, Morgan says. First sign of trouble, I want to know. He climbs through the forward hatch into the pressurized nose compartment. The interior is cramped despite the B-29's size 11. Crew members will operate from this space and the rear pressurized compartment for the next 14 hours. Bombardier Lieutenant Howard Sullivan is already at his station, checking the Norden bomb site. Navigator Captain Frank O'Connor spreads maps across his table, plotting the route to Bangkok and back 1,500 miles each way over enemy-held territory with no friendly bases for emergency landings. Morgan settles into the left seat, running through pre-start checklists with his co-pilot. First Lieutenant David Chun. The cockpit is more sophisticated than any bomber Morgan has flown pressurization, controls, remote gun turret systems, an autopilot capable of maintaining altitude and heading 4 hours at a time. But sophistication brings complexity, and complexity brings new ways for things to fail. Crew check-in. Morgan calls over the intercom. One by one, his crew reports ready. Bombardier, navigator, flight engineer, radio operator, radar operator, central fire control gunner, and for additional gunners manning the remote control turrets. 11 men whose lives depend on the aircraft holding together and the engines continuing to run. Tower. This is Dottie Lead requesting taxi clearance. Dottie Lead. You're cleared to taxi. Good hunting. Morgan starts the engines in sequence 1, 2, 3, 4. Each height are 3,350 coughs to life with a roar that vibrates through the airframe. Cylinder head temperatures immediately begin climbing. Even on the ground, idling at low power, the engines run hot. Flight Engineer Technical Sergeant Bill Morrison monitors the gauges intently, calling out numbers. Number 2 at 220 degrees and climbing. Number 3 at 215. Keep watching them, Morgan replies, advancing throttle slightly to begin taxiing. The B-29 rolls forward. Its weight 140,000 pounds fully loaded with fuel and bombs pressing down on tyres that leave deep impressions in the tropical soil. 48 bombers taxi toward the runway in formation, the largest B-29 raid yet attempted. They carry 500-pound general-purpose bombs, enough high explosive to obliterate the rail yards and cut Japanese supply lines running through Thailand into Burma. It's a strategic target, carefully chosen for this first mission to demonstrate the B-29's capabilities. At the runway threshold, Morgan runs through final checks. Control surfaces free and correct, trim tabs set, mixture rich, props full forward. Cowl flaps wide open for maximum engine cooling. Behind him, the bomb bay holds 2,500-pounders secured to their racks. Fuel tanks are topped off 7,830 gallons of aviation gasoline. Enough for 14 hours of flight if everything goes according to plan. Dotty lead, you're cleared for takeoff. Morgan advances all four throttles to maximum power. The engine's roar becomes deafening despite the pressurized cabin's soundproofing. The bomber accelerates down the runway, slowly at first, then building speed as 8,800 horsepower overcomes 140,000 pounds of inertia. 50 knots, 80, 100. Morgan watches the airspeed indicator climb while Morrison calls out engine parameters. Temperatures rising across the board. Number 2 at 240. That's approaching red line. We're committed, Morgan replies, keeping his eyes on the runway. They're too heavy to abort now. Stopping would mean running off the end of the runway and likely exploding. The only option is forward. 120, 130. At 145 knots, Morgan eases back on the yoke. The nose lifts. The main gear breaks contact. Dauntless Dotty climbs into the hazy Chinese sky, and Morgan immediately orders, gear up, reduce power to climb setting. As the landing gear retracts and Morgan throttles back slightly, the cylinder head temperatures stabilize. Number 2 drops to 235 degrees, still hot, but within acceptable limits. The B-29 climbs steadily at 800 feet per minute, heading southwest toward Thailand while 47 other bombers form up behind. For 6 hours, the formation flies across occupied territory. Below them, Japanese-controlled cities and military installations pass unnoticed. The B-29s fly at 28,000 feet, high enough that the pressurized cabin maintains comfortable breathing pressure while enemy fighters struggle to reach them in the thin air. This is what the B-29 was designed for, high-altitude penetration missions beyond the reach of conventional defenses. But the engines continue their struggle. Every hour, Morrison reports rising temperatures. Number 2 remains the hottest, consistently running 10 to 15 degrees above the others. Morgan adjusts mixture settings, trying to find the sweet spot between power and cooling. Too rich, and they waste precious fuel. Too lean, and the engines run even hotter. Navigator, how far to target? Morgan asks. 40 minutes at current speed, O'Connor replies. In the nose, Bombardier Sullivan prepares the Norden bomb sight, synchronizing it with the aircraft's ground speed and altitude. The bomb sight is a mechanical marveler, sophisticated analog computer that calculates bomb trajectory, accounting for wind, altitude, airspeed, and bomb ballistics. But it only works if the pilot maintains steady, level flight during the bomb run, regardless of enemy fire. Enemy fighters, 10 o'clock high. The call comes from the central fire control gunner, Sergeant Mike Kozłowski, who manages the B-29's defensive armament from a sophisticated sighting station in the pressurized cabin. Morgan spots them 4 Japanese Ki-43 Oscar fighters climbing desperately toward the bomber formation, but the Japanese pilots are struggling. At 28,000 feet, their engines are gasping for oxygen, producing barely half their rated power. The Oscars climb sluggishly, trailing the much faster B-29 Sekunde. Hold fire unless they close within range, Morgan orders. No sense wasting ammunition on targets we're outrunning. It's a surreal moment being pursued by enemy fighters yet feeling almost untouchable because of altitude advantage. This is exactly what the B-29's designers intended, a bomber that operates above the effective ceiling of enemy interceptors, making it nearly invulnerable to fighter attack. The Oscars fall behind, unable to match the Superfortress's speed and altitude. The formation continues unmolested toward Bangkok. EP in 2 minutes. O'Connor calls out the initial point where the bomb run begins. Roger, Bombardier, you have control. I have control. Sullivan confirms. Taking over the aircraft's heading through the Norden bombsite's autopilot coupling. For the next 7 minutes, Sullivan will fly the aircraft electronically, making minute adjustments to keep the target centered in his sight. Below, Bangkok spreads across the landscape a sprawling city on the Chao Phraya River, with the rail yards clearly visible as geometric patterns of tracks and buildings. Anti-aircraft fire begins. Black puffs of smoke appearing at their altitude as Japanese gunners fire 88mm and 105mm shells set to detonate at 28,000 feet. Flak, Morrison reports unnecessarily. Everyone can see it, can hear the occasional fragments pinging against the fuselage when bursts come close. Morgan holds the B-29 steady despite every instinct screaming to maneuver, to jink, to make himself a harder target. But evasive action ruins the bombsite's calculations. They must fly straight and level, accepting whatever the enemy throws at them, trusting that altitude provides protection. Bomb bay doors open. Sullivan announces. The aircraft shudders as the massive doors swing down into the slipstream, increasing drag and requiring Morgan to add power to maintain airspeed. Number 2's cylinder head temperature spikes to 255 degrees. Number 2 engine critical temperature. Morrison shouts. How long can it hold? Morgan asks, not taking his eyes off the instruments. Unknown. We're in uncharted territory. Sullivan's voice cuts through the tension. Bombs away. 2,500-pound bombs drop from their racks, tumbling downward toward the rail yards for miles below. The B-29 lurches upward, suddenly 10,000 pounds lighter. Sullivan toggles the bomb bay doors closed, reducing drag. Good hits on target. The tail gunner reports, watching explosions blossom across the rail facility. Navigator, heading home, Morgan orders, banking the bomber into a turn that will take them back across Thailand, Burma, and into China. But number 2 engine won't make it home. The temperature continues climbing despite every adjustment Morgan attempts. At 270 degrees far beyond redline, the engine begins failing. First a loss of oil pressure, then a drop in manifold pressure. Finally, a grinding vibration that signals imminent catastrophic failure. Shutting down number 2, Morgan announces, pulling the mixture to idle cutoff and feathering the propeller. We're flying home on 3 engines. The B-29 can fly on 3 engines barely. Morgan transfers fuel from the dead engine's tanks to maintain balance. He reduces airspeed to conserve the remaining engines. The bomber drops to 22,000 feet, still high enough to avoid most fighters but lower than optimal. The flight home takes 7 hours on 3 engines, every minute a test of Morgan's skill and the remaining engine's endurance. They cross into friendly territory just as daylight fades. Chengdu Airfield appears ahead, marked by runway lights that represent safety, survival, home. Morgan lands dauntless, dotty with one engine dead and to others running dangerously hot. The touchdown is firm but controlled. As the bomber rolls to a stop, Morgan sits back in his seat, hands shaking from 7 hours of constant tension. "First mission complete," he says quietly. The ground crew swarms the aircraft immediately, already working to replace the failed engine before the next mission. Because there will be a next mission, and another after that. The B-29 is operational now, proven in combat despite its flaws. The strategic bombing campaign against Japan has begun. Eddie Carlson, now working at the Wichita plant, hears about the Bangkok raid through official channels. 48 B-29s launched, 42 reached the target, 6 turned back with mechanical problems, mostly engine overheating. 1 was lost to unknown causes, possibly ditched in the ocean. The mission is classified as a success. But Carlson knows the truth behind those numbers. 6 aborts out of 48 means or 12.5% mechanical failure rate. One aircraft lost means 11 crew members dead or missing. These are the costs of fielding a bomber that was rushed from drawing board to combat in 18 months. Yet there's no alternative. The B-29 is the only aircraft capable of reaching Japan. It will carry the war to the enemy's home islands. Will eventually drop incendiaries on Tokyo. Will ultimately deliver atomic weapons that end the war. All of it made possible by engineers who couldn't believe how fast they built it. By workers who assembled it despite knowing its flaws. By pilots who flew it into combat despite the risks. By a nation that demanded the impossible and somehow achieved it through determination, innovation, and the willingness to accept terrible costs in pursuit of victory. The B-29 Superfortress built to fast, deployed to soon. Plagued with problems that killed crews and aircraft, nevertheless changed the course of history. Not because it was perfect, but because it was ready when it was needed most.